All right, class. Hopefully you have been handed this or you have this. This is your, let's see, your formula sheets. All right, so I want to just kind of show a few things over here. On the left-hand side, we have our basic identities. We started doing this in chapter 5.1, and we added to them as well, right? Especially the Pythagorean theorem kind of expanded that form right over there. What we want to do today is 5.5. So we're going to do something called the product of sum formulas. Right, and the next one, the second half of the page. Let's see, there it is, okay. So 5.2, some of those we know, the double angles we know, and then there's three forms for cosine. The cofunction of theorem, we learned that all in chapter 2. 5.4, the half angle formulas, we learned that last time. There it is with the plus and minuses in front. And then the other part is when you learn the sum to product formulas right over here, these guys. So perfect. Okay, before we get going, we got to do some other little parts here, but let's go. So 5.5 is called additional identities. It's pretty much everything we have not done so far. So this really breaks down into two different parts in this section. It's almost like the last two remaining things. The author decided to sort of like squish them into one section instead of really dividing them into two. But they almost like really should be two different sections because they deal with really two different things. So the first part is this. Let's talk about identities that involve inverse functions now. So all the stuff we've learned so far, so 5.1, 5.2, 5.3, 5.4, but especially 5.2. Let's see how we involve inverse functions into this process. So let's go back real quick here though. Let's go back to the sum formula for sine right here. Sum is a plus b, sine of a cosine b plus cosine a sine b. That might just be very, very important in what we're going to do right now. So let's go with it here. So here it is, evaluate. Exercise 1, evaluate this right here. I need to evaluate sine inverse of 3/5 plus arc sine or arc tangent actually 2. All right, let's write that down. And also just to remember, right, whenever you have sine to the -1 power, right, that means inverse. And when you say arc tangent, that actually means tangent inverse. So these two mean the same notation, right? Not the same trig function, same notation. A -1 here means inverse, arc means inverse. Okay, so how do we deal with this? So here's what you should think about and should know. Whenever you have a trig inverse function, this whole thing really is a angle measurement, right? Because remember, inverse functions give you back to your angle. So if you think of this as an angle, and think of this as an angle, you really have two angles that are being added together. And then you take the sine of that angle. So if you think of it, let's see, if I just do this, if I say this is sine, I'm going to say, you know what, this guy here is going to be an angle for me. Call it A. There's a plus sign. This guy's going to be an angle for me. Call it B. Okay, so what I'm trying to do is I know trig functions. I'm trying to go to the inverse of them, get my angle, add those angles together, and then take the sine value of it. And I don't even know what those angles are, right? So I don't really even need to know what those angles are as long as I have this little, I call it a hack, right? The sine of A plus B hack. It says this, I can get the addition of my angles and then get the sine value of it as long as I can take the sine of my first angle, cosine of my second angle. I add it with cosine of my first angle and sine of my second angle. That's all I need to get. Okay, then how do we get the A angle out of all that right there? And how do we get the B angle out of all that? Let's go for it. Once you do about 2 of these, then they become pretty easy. So let's go with it. First things first, I got to convert sine inverse of 3/5 into something I can kind of think through. Okay, and I can do the same thing for arctangent of 2. So here's what we're going to do. I'm going to say the angle that we have, angle A, is equal to the sine inverse of 3/5. And I know that the sine value is labeled as y over r. So if I create a little triangle, pretend it's a right triangle, I'm going to call it an angle A on the bottom there. That means 3 is here, and then 5 is the hypotenuse. True, true. By Pythagorean theorem, I just need to know what my x value is that right? So this is the x squared, this is 9, that's 25. Subtract 9 gets me 16. And then take the square root of 16 gets me 4. Perfecto. Okay, so I know that this side of my triangle is 4. Again, just got to think with me for a little bit. We'll get there, we'll get there. And the next one, angle of B. My B angle is going to be, let's see, it says it's tangent, arctangent, or tangent inverse of 2. But I can write tangent of being 2 over 1. It's easy. Okay, definition of tangent is y value over x value. Or you can actually just even say what? Opposite over hypotenuse, right? That's technically what it means with angles. So opposite side is 2. I'm sorry, adjacent. Opposite over adjacent for tangent. There you go. Sorry. So it's going to be opposite over adjacent. So now I need my r value or my c value, depending on how I want to read it here. So x squared plus y squared is equal to r squared. That becomes a 1, that becomes a 2, that becomes an r squared still. So about 1 plus 4, that makes 5 for an r squared. Therefore, r equals square root of 5. And there it is for the hypotenuse. All right, so the trig form that we have is this right here. So do we have enough information to plug in everything we know for sine of A, cosine B, cosine A, and sine B? I think we do. So for angle A, the sine value for angle A would be y over r. That's true. We already have that, huh? Because sine inverse and sine would cancel each other out. For cosine, it's going to be the adjacent over hypotenuse. Okay, plus cosine of my first angle would be adjacent over hypotenuse, and sine of B would be opposite. Let's see, now I'm looking at angle B now. I'm looking at opposite over hypotenuse. And if I multiply these guys together, 3 times 1, 5 times root 5. I'm going to leave it just like that. Plus 4 times 2 is 8. And how about a 5 root 5? And putting it all together, how about an 11? Those are the same exact denominator. I can add them up. They're like terms. They're good. So 11 over 5 root 5. And the question is, Mr. Ng, would you rationalize that square root of 5 on the bottom? No, I would not. This would be a little easier to look at right there. All right, one that's very, very similar for you guys to try it, possibly be ahead of me. Exercise 2. Can you evaluate this? Cosine of tangent inverse of 1/2 plus sine inverse of 1/2. All right, give you guys about 30 seconds. And start it yourself if you can. Help your neighbor out as well if need be. Try to work with your neighbor to finish it off. Give you guys a 30-second head start. All right, let me slowly start my way into solving the problem. If you want to still keep on going with yours, that's fine, but I'm going to say angle A is tangent inverse of 1/2. Angle B is sine inverse of 1/2. And if that's the case, then I have cosine of A plus B, and the formula for that is cosine of A cosine of B minus sine A sine B. So there's only one angle that I know right here, sine inverse of 1/2 and sine of B. That's my only one right there. The rest I gotta go find. So let's set up our little triangles here then. Triangle A, Y, and X. So how about 1 and 2? Use Pythagorean theorem. So 1 squared plus 2 squared is equal to r squared. How about a 1 plus 4? Okay, this is very similar to something we did before. So how about a hypotenuse of root 5 for angle A? Angle B, sine is y over r, so y is the opposite, r is the hypotenuse, and now we'll go looking for the adjacent side here. X squared plus 1 squared is equal to 2 squared is, x squared plus 1 is equal to 4. How about subtract 1 from both sides? Voila. And how about x equals root 3? Okay, all yours. Can you finish it off? So here's my formula, and from the previous slide, cosine of A, that would be angle A, and that would be 2 adjacent over hypotenuse. Cosine of B would be adjacent over hypotenuse minus opposite side over hypotenuse, and then again opposite side over hypotenuse, but that's for the B angle. Okay, so notice right here you could actually just cancel the 2's, right? If you do that, you're not going to wind up with common denominators. So in this case, it is so much better to leave the values as they are. 1 goes there because 1 times 1 and 2 root 5. And putting it all together gives us 2 root 3 minus 1 over 2 root 5. All right, and again, that is the exact value of whatever those terms were. I added the angles of those terms together, and I now have the trig ratio of that, which is pretty cool. All right, one more before we go into part 2 here. Find this for me. Okay, a little bit tough. Let you guys try it. All right, so let's do this here. It's a 2 something. So hopefully that reminds you of something on your formula sheets. Kind of think back. Sine of 2 something. Sine of 2 times an angle measurement. Oh yeah, hold on. That's going to be sine of 2a. I think I remember that. That's called the double angle formula for sine. Yes, the double angle formula for sine. Look at your formula sheet. It's going to be 2 sine of a cosine a. There it is. Except ours is in terms of tangent. So we're just going to declare that angle A is technically tangent inverse of x. Okay. Put your thinking caps on. This will be a little bit of a tough one here. We are going to set up our little triangle. And so remember, it's almost easier to use not X's and Y's, but A's and B's here. But here's where, again, the stuff happens. Tangent is defined to be my Y coordinate over my X coordinate, right? So don't forget these are coordinates here, and that X next to tangent is a variable, right? Variable X, coordinate Y, coordinate X. So almost like easier, we're going to write this out. Maybe make an A and a B instead of X and Y. All right, if that's the case, X is going to be here, and then that's going to be a 1 down there. So I do not know my hypotenuse. But if one is X and the other one's 1, I'm going to use the Pythagorean theorem to find out what this C value is. Oh, you know what? That should have been a C right there. I'm going to change it to A, B, and C. Right there. So my A value is X, my B value is 1. If I'm going to have to solve for, technically it should be C, but there's an R. So x squared plus 1 is equal to r squared. Therefore, r is equal to the square root of x squared plus 1. That is going to be my hypotenuse right here. That is my hypotenuse. But then do I have everything I need in order to fill in cosine of A or sine of A and cosine A? I think so. Let's go for it. So 2 comes down. What is the sine of my A angle given that triangle? So sine is opposite over hypotenuse. That's exactly what it is on the chart there. Cosine of A is now adjacent over hypotenuse. In this case, it's adjacent over hypotenuse. And then I multiply. So 2 times x times 1 is 2x. That's easy. The other one, what happens here? There's a root of x squared plus 1, another root of x squared 1. If you multiply those together, it just becomes a perfect square of x squared plus 1. So we can drop the square root completely. There it is. That is the final answer to this. Okay. That is part 1 and done. Part 2 of this section now deals with the last remaining identities that we can make out of the trig functions. So notice we're going to do something called product of sum. And then we're going to do some other ones here. So this one probably is the best one to start off first. So we are going to do sum to product in a little bit here, but let's go back. Let's go over here. Let's take a look at this part right here. Get a highlighter. Yep, it's this one. That sum identity and that difference identity. I'm going to write them backwards just because it's a little easier to do some stuff here backwards. All right, so let's go with it here. So I'm going to write the top one. I'm going to write as sine of A cosine B plus cosine A sine B. And that's the equivalent to sine, the addition value for sine. Just kind of wrote it on the other side. Everybody okay there? All right. I'm going to write the difference formula as well. So sine of A cosine B minus cosine of A sine B is equal to sine of A minus B. All right, this one particularly you don't need to write down. If you don't want to, you can just kind of pay attention as we go. You definitely have to write down the problems and the exercise problems. But think with me here. Since we have done adding equations together, let's do this here. Can we add these two equations together? So what's going to happen when we say sine of A cosine B plus sine of A cosine B? Makes 2 of these. All right, then what happens when you say cosine of A sine B plus a negative cosine of A sine B. These guys cancel. They're gone. And I'm left with this little formula right there. 2 sine of A cosine B is the same thing as sine of A plus B. Oh, remember we added these together? Wow, look at that. We added these together, but they're actually, one is a sum identity, one is a difference identity. Okay, one more step. Since we're trying to do product to sum formulas, here's what we're going to do. We're going to divide by 2 on both sides. So I'm left with sine of A cosine B is equal to 1/2, just divided by 2. That's all I did, or multiply by 1/2. Put these big old parentheses here, or brackets, and parentheses. There it is. There's our first product to sum identity. And I could just do this for all the other ones as well. If we did the exact same piece for another one here. So let me just write it out. There's going to be 4 of them. And all we do is we just pick one of the sum identities, one of the difference identities, and we just see what happens. All right, if you were to subtract these guys, you would get this, cosine of A sine B. So let you write that down. If you were to subtract these two, then the front ones cancel. And the middle is actually double. All right, so these guys are called product to sum formulas. They take a product right here, and on the other side, it's just the sum of the angles, the trig functions. All right, 2 more to write down, so those 2 right there. And if you were to take the cosine values, you'd get this, cosine of A cosine B is equal to 1/2. And then if you were to subtract the cosine sum and difference identities, you get this. There's all 4 of them. Right here, let you copy that down. Give it a little bit of time. You can pause the video if need be. All right, let me start as well here. So now let's do some work with it here. So first things first, just to verify that this is true, that's all I need to do. I just want to make sure if I plug in some angles that the right side and left side will equal each other, and at least gives me some confidence like, yeah, this is an identity. So let's go with it here. So find the product formula for number 3, which is this one here. So it's cosine is 1/2 cosine of A plus B plus cosine of A minus B. All right, we're just going to plug them in. That's all. We're just verifying that the left side and the right side will actually equal each other. So cosine of 30 degrees, cosine of 120 will be the same thing as 1/2 of cosine of, okay, let's see, A plus B added together. So 30 and 120 makes 150. And then we have 30 minus, carefully here, 30 minus 120, negative 90. Okay, sounds good. All right, so let's go with it here. So I think we know this here. So cosine of 30 degrees. Now the formula sheet that I gave you, if you flip the other way on it, you'll see that there is the unit circle on there. So if you need to get to the unit circle real quick here, go for it. And cosine of 30 degrees is root 3 over 2. Cosine of 120 is negative 1/2. And get ourselves 1/2. Now we have so cosine of 150 according to the unit circle is negative root 3 over 2. And then cosine of negative 90 is 0. And we're running out of space. But if you don't multiply the left side together, right there, exact same thing. I just moved up the numbers to the top of the screen because we're running out of room. And I got myself a negative root 3 over 2. Or 4, sorry, yeah, 4. This one would be a 0 there, so how about a negative root 3 over 4? Perfect. They checked out. You could put a little check mark, or you could write QED, and that would be just fine as well. QED for this little guy. Okay. How about this one? So I have a product. It's 10 cosine of 5x times sine of 3x. Can we write that as a sum or difference? All right, let's go with it here. So if I'm going to rewrite this here, it's going to be 10 cosine of x, 3x. We just need to figure out which formula we're going to use. So cosine here in front, sine in the back. I'm flipping through my page as well here. That's the second formula we had written down, right? Yeah, that's the second formula we wrote down. All right, but don't be too mindful about the 10. The 10 can just kind of sit there in front. What we really are concerned about is this right here. So kind of thinking, okay, that's cosine of A sine B. And the formula for it, right, is 1/2 sine of A plus B minus sine of A minus B. Okay, with that, there we go with it. So careful with the 10 in front. So I got a 10 in front as a multiplier over this whole entire thing, right? So one got 1/2, got the sine, got the 5x plus 3x. I got that one right there, minus the sine of 5x minus 3x. Okay. And let's simplify this as much as we can. So the first thing I'm going to do is that 1/2 and 10. 10 is 5. It's easy enough there. Don't forget a parenthesis, right? Because that 5 is multiplying both of those things. So this is sine of 8 and 5. 5 and 3 make 8. Perfect. And 5 minus 3 make 2. And that is it. We got it from a product formula down to a difference formula, technically, right? Right. Okay. And now, we're going to jump real quickly here to another spot. I'm going to jump to here first. I'm going to jump to the sum and product identities. So first things first, before we take a look at those. Well, we've been adding angles together. And so what we kind of start thinking about is this. If say, you know what, if we have two angles that have been added together, I can switch them the other way by doing this. So I got so many angles to keep track of. So that little funny symbol, that's alpha. So I'm going to use Greek letters one way and English letters the other way. So if alpha represented A plus B, and beta is kind of like a B, but it's like extended down a little further on this little piece right here. And usually it comes out in this way as well. Just a little bit. So beta is A minus B. If I were to add these guys up like this, again, stroke of genius of Ptolemy, right? Ptolemy sitting this Saturday morning, nothing else to do. He's just contemplating trigonometry, just having so much fun. And he says, okay, if that's the case, this is alpha plus beta. He's going to give me, oh, this is interesting. A plus A will give me 2A, but a B plus a negative B will be canceled. Oh, yeah. So let's do this. Divide by 2. And I got myself something about angle A. I know something how angle A can break down. Okay, going the other way, let's do that again. So alpha is A plus B, beta is A minus B. Instead of adding, we're going to subtract now. So alpha minus beta is equal to A minus A is gone. B minus a negative B becomes B plus B, which is 2B. Perfect. Divide by 2 and makes this one. So here it is. We're going to substitute these values and we're going to create something called the sum to product formulas. Let's go for it. Okay, so let's do the first one and I'll give you all the answers to the other ones. And then we'll do a problem. So let's go for it here. So you remember this formula. Yeah, it's supposed to be sine. Sine of A cosine B. That little N right there, I'm writing a little bit too fast. So this is sine of A cosine B equals 1/2 sine of A plus B plus sine of A minus B. So stroke of genius of Ptolemy again. Here it is. We're going to substitute. Anytime you see an A, we're going to do alpha plus beta divided by 2. Anytime you see a B, we're going to do alpha minus beta divided by 2. Let's go. So sine of alpha plus beta divided by 2. Cosine of alpha minus beta divided by 2 equals 1/2. And then this. This is just going to be sine of alpha. Right? Because remember, by definition, sine of alpha was just A plus B. This is sine of beta, because by definition, as we made it, beta was just A minus B. Okay, so what we want to do is we want to solve for the right-hand side this time. Let's multiply by 2. And here's what I got. You can keep up writing it out. So 2, just put the 2 on the other side. I have solved for the formula going the exact opposite way. All right, so notice this is now as a sum, and we're going to get a product out of it. That's what we want. Okay, that's one formula. Let me give you the other ones here. In fact, let's do this. Let's write the sine of alpha plus beta. We should write that on the left-hand side first, and then we can do all the others. All right, so let's do that. So let me write them out for you here. Give you guys a little bit of time. And we'll just wait for everybody else to get in them. Just kind of write them real quickly out. That was super quick. Okay, give you guys a little time to copy them. And if you want to pause the recording, that's fine too for now. And I'll give you about 20 seconds with the recording paused. All right, hopefully that was enough time or needed a pause in the recording. That's what we have here. Okay, so this takes us from sum and gets a product out of it. That's what we want to do there. Okay, let's do this here. Let's verify that one of these formulas actually do work. Jump back to this one here. There it is. All right, I want you to verify that this formula is true and it works for these degrees at least the 30 and the 60 and the 90. Give you guys a head start since we've done something like that before already. All right, and we're just verifying that 30 degrees, and 90 degrees works. All right, cosine of 30 degrees plus, let me simplify this out. I could have simplified it over here. I just want to make sure I simplify over here. This is 2 cosine. Let's see, 30 plus 90 is 120. Divided by 2 makes 60. 30 minus 90 is negative 60. Divided by 2 is negative 30. Interesting. So there it is. Cosine of 30 plus cosine of 90 is the exact same thing as 2 cosine 60 cosine negative 30. Interesting. Okay, let's plug in the values. Cosine of 30 degrees is root 3 over 2. Cosine of 90 is just a big old 0. Cosine of 60 is 1/2. All right, cosine negative 30 is root 3 over 2. And again, we're just verifying that the right side and the left side will give us the same value. That's all. And they sure do, right? One side will give us root 3 over 2, and the other side will give us root 3 over 2, as a pair of 2's will cancel on the right-hand side. All right, down to the last 2 example problems we have. All right. Can you rewrite this as a product? So it looks like I have a, technically we call it a sum, right? All right, from the ones I wrote down a little while ago, let's see, formula 1, 2, 3, or 4. So it's 2 cosines and it's in the middle. Okay, so let's see, let me go back from this screen right here. Which one is it? First one, second, third, or fourth? And it looks like the last one right here. Yep, cosine, cosine, and there's a subtract between the two. So instead of doing that, I could just do this right here. Okay. So negative 2 sine of the addition and then sine of the subtraction. All right. Let me just rewrite it real quick. It's easier just for me to rewrite it. All right, let's go with it here. So according to last slide, it's negative 2. It's sine of the addition of these two divided by 2. So let's see, 5x plus 3x is 8x divided by 2 is 4x. Perfect. Then it's sine of the subtraction of these two here. So 5x minus 3x is 2x divided by 2 is just x. That's good. So there's that where that formula came from. And then there's this formula comes from, just an x. And that's it. We've changed it from technically a subtraction of 2 trig identities or trig functions to a product of 2 trig functions. All right. And proving identities. I know we started this in 5.1. Not sure if you like it too much. I was going to say your favorite and be sarcastic, but that's not cool either sometimes. Okay, so go for it. You guys, give you guys a 30-second head start. See if you can make the left side and the right side be identical. All right, that was about 30 seconds or so. So I got a negative. Tangent is just sine over cosine. think we just did this formula. Cosine minus another cosine, right? It's -2. It's the sine of adding these guys together divided by 2. So let's see, it's 3x plus 1x is 4x divided by 2 makes 2x. That's alpha and beta if you want to kind of keep them in mind if you're looking at the formula there. So we got a 3x plus 1 more x makes 4x divided by 2 makes 2x. And sine of, according to the formula, it's 3x minus x, which is 2x divided by 2, which is just x. Perfect. Okay, find the formula for this one. I need two sine functions being added together. So I got a 2 value here, sine of, and again, this is now going to be subtract, oh, divide, that's right, add and divide. 3x plus 1x is 4x divided by 2, 2x. And then cosine was that right there. Okay, I think we are good. 2's are gone. Sine of 2x is gone. Now we're left with a negative sine x over cosine x, and then which is exactly what we wanted to prove. So QED at that point. All right, and that is the end of the lesson for today. And look at the schedule to see how we're going to do the following days. All right, and have a wonderful day.